So it takes from here all the way to compressed and then all the way back. So it's going to go this way and then all the way back to the most stretched position. That's 1.867 seconds. So does that make sense? Yeah, remember the whole thing, if you go this way and then you go this way and then go back, the whole thing was like 2.8 seconds or something, right? So it makes sense that to go all the way to the stretch, it would be a little bit less than that, which would be 1.86, okay? How about the other one? How many seconds does it take the kinetic energy to equal, what was the question saying? Something like the kinetic energy to equal twice the potential energy or 3 times the potential energy. I mean, the problem could basically ask anything, right? So then you would say the kinetic energy, if it's twice the potential energy, so you have half mv squared is equal to 2. And then if it's twice the potential energy, you got 2 half kx squared. And the potential energy, sometimes we write PE or sometimes we write U. And then you have here 2 cancels the 2, half. And then the mass was equal to 4 kilograms. And then velocity squared is this equation, right? 6.985 squared cosine squared of the parentheses, right? And that's equal to what? K, which was 20, and then x squared, which is this thing. Sine squared. Now if I divide both sides by cosine squared, I get tan squared. And I could take all this stuff, bring it over here. So I have here 2 times 6.985 squared divided by 20, which was the K, and then the 3.124 squared is equal to tan squared. Okay? And then I'm going to take the square root of that. Square root of that. That means I don't even need to square this in the first place, right? So I could just have square root of 2 cancels the 20. So let's see here. Okay, that means I can cancel the 20 here, and I'm going to have 2 over 20, that's 1 over 10. And then this is just going to be basically 6.985 divided by 3.124. And then you're going to have, it's equal to tangent of this angle. So let's see what this is equal to. 6.985 divided by 3.124. divided by 10 square root. And that's equal to 0.707058. Okay? So that's equal to tangent of whatever's in the parentheses, right? So then you take the inverse tangent of that. Okay? So then you're going to have 0.615. Actually, what I should have done here is when I took the square root, tan of this is equal to plus minus of this, right? So I have plus minus. So if I take the tan inverse, I'm going to say tangent inverse of 0.707058 So the thing in the parentheses is 0.615. So you have 2.236 T plus 3.6793 is equal to 0.615447. Okay? Or it's equal to negative of that, right? Because you have the negative option. 2.236 T plus 3.6793 is equal to negative 0.615447. Okay? But of course this is going to yield for me negative times. So I'm not interested in negative times. So now let me start adding pi. Every pi n, my answer will repeat, right? So if I add pi n to this, what do I get? If I add 3.14 to that, I get 3.757 when I added just n equals 1. If I subtract this number from it, I get a small tiny bit number, positive number. And I divide that by 2.236 and I get 0.0347. So the first time when that condition will be satisfied is 0.0348 seconds. So initially, right after the initial condition of the problem, that kinetic energy being twice the potential energy is going to be satisfied. How about this one? Well, when you put n equals to 1, you get a number less than this, so we cannot buy that. So the next time when that condition will be satisfied is when n is equal to 2, okay, and then n equals to 2. So when I put n equals to 2 here, what do you get? 2 pi minus 0.615447, 2 times pi, minus this, I get 5.6677, then I subtract this number, and I divide that by 2.236. So the second time is going to be 0.88928 seconds. So basically, the block was going to the left right away, and then it's going to go compress right away as it comes back. That's the second time when that's going to be satisfied. Then it's going to take a little while until it goes to the other end. Okay? So the third time it's going to be satisfied, you put 2 over here, and then you have 2 pi plus 0.615447. Then you subtract 3.6793, and then you divide 2.236, and then I get the third time 1.43977. And then if I want to do a fourth time, then it's going to go, basically it's going to go back right here, immediately it's going to be satisfied. Then it's going to go back right away, it's going to be satisfied. Then over here right away, and then coming back. So there should be 4 times that it's satisfied within one period. Okay? So then you put n equals to 3 over here. Okay, so then you have 3 pi minus 0.615447. Okay, minus 3.6793 divided by 2.236. Now you get 2.294 seconds, and that's less than one period. So 4 times less than one period. So this is a pretty good use of trig as well in analyzing this problem. So this is a really good example of oscillatory motion and analyzing the motion and all of the different kinds of questions that we can ask. Thank you.